Hey everybody, this is Nathan Case. Today we're going to go through automatic remediations, mostly from GuardDuty, but this also works from Security Hub or any of the other detective services on the left hand of this slide. Today is not going to be a slideshow. Historically, when we do these, we show a slideshow and everybody gets to follow along and we talk about things. We've even done some tabletop sorts of things in the slideshow, and that's always fun, but we kind of thought today we'd try something different. We're actually going to look over my shoulder while I work on a remediation plan for AWS. We will be, for the first half of this, or for more than the first half of this, actually, we're going to be using AWS services only to do the remediations. That means that we're going to use a lot of AWS CloudWatch. We're going to use Lambda, and we're going to use Step Functions. We're also going to talk about SSM automation, and we're going to talk about SQS and how you can potentially alternate or change out some of the pieces inside of this setup with those if they work better for you, and kind of why that would be and when you would want to do that. As we look at this, then we'll go all the way through to the point where the Lambda function is kicking off a secondary or a remediation action, and watch what happens in that action. Today should mostly be over my shoulder. We're going to take a couple of pictures and bring up this slide again a couple of times so we know where we're at, what we're actually doing, and make sure that we use this slide as kind of our guidance as we go. Today, you're going to see me make some mistakes, which is kind of fun. Actually, I already did all of the coding for this and kind of recorded it. So yeah, I know I'm not doing coding right as you're watching, but still. You do get to look over my shoulder from that point of view, and I do make some mistakes and go back and fix them. I'm showing you that more so that you understand what types of mistakes can happen, and realistically, it's an honest mistake. So it's kind of a fun, hey, look, this is what would have happened had we just gone ahead and put this into production. A lot of the things that we're going to do in here need to be tested. They need to be reviewed. You need to try them a bunch of times, and we'll talk about how to test them when we're doing this, but you need to make sure you test them before you actually put them into action. One of the last things that we'll see here is a step function running, and the step function is a forensic step function. And all of a sudden it fails, and I won't ruin it for you too much, but obviously the instance that it was working on the test is no longer there because I've tested it so many times. So do make sure that you test things, do make sure that you plan on how to test things, and as you work this through, make sure that you have a good communication set up with both your management and your development crew so you don't break anything accidentally. So we're going to go to CloudWatch. So pull up CloudWatch. We get the basic dashboard, right? I'm sure you guys have all seen the overview before. Lots of fun. This is a pretty unused account. Nothing horribly interesting here. As we go through this, obviously I've got a couple of DynamoDB tables running. Nothing else particularly interesting. Effectively, what we want to do is jump down to events. Events is a great place to start. When we look at this, we've got events, rules, and events buses. We're not going to get into buses today. We're really only going to focus on rules. We probably really ought to talk about event buses at some point in the near future. But for right now, let's focus on what we've got to do. CloudWatcher test is our test event that we've got turned off right now. Really, really simple. We've got a basic pattern that we'll walk through here in a second, and a basic action, a target that we want to have executed if this pattern shows up. So this is what it looks like. We go to rules. We're going to go ahead and create a rule. Pretty straightforward. Patterns and schedules. So schedule is legitimately just like a cron tab. Totally old school. Really neat stuff. If you do have questions about how to do it, it's a little different than cron tab. Go here, take a look. But not particularly interesting. If we go here, however, we have kind of a weird thing. If we've got the services name over here, let's go ahead and do the dropdown. We've got all sorts of stuff here that we could look at and play with. Anything you happen to be doing in AWS, for the most part on a services level, you can go ahead and have a CloudWatch rule set up for it. And different items will give you different things. So let's go ahead and say like transcribe. Really, we just have a job state change, which makes a lot of sense, right? I mean, it's either working, it's finished, or not. We've got auto scaling. I have a couple of different events here. In this case, however, we want to specifically look at GuardDuty. So we'll go ahead and start with GuardDuty, and we'll drop down the events list. Now, the events type here is really all events, which means anything that goes to GuardDuty, anything at all. We have API calls via CloudTrail, and that's going to be things like GuardDuty is being turned on, GuardDuty is being turned off. Somebody's running a describe event against GuardDuty or the findings. Kind of the more setup configuration stuff, maybe. And we also have GuardDuty Findings, which is probably the part that most people are interested most in. the things that actually GuardDuty says, hey, there's a finding here, you need to do something about it. Most likely it's a bad thing. So for today, we're going to focus on findings. And what that does is it'll build out this little JSON pattern in the bottom. Now, what this is, if we hit edit, is really a source, which is a service, and a detail type, which is a portion of the JSON that we want to match. So if we look at the GuardDuty event, what we'll see is that the source is indeed this exact string, and the detail type is exactly this string. So when we see this in this configuration where we have the square brackets, a comma, another call out, and then more square brackets, is we're saying and. So in this case, we're saying source GuardDuty and detail type GuardDuty finding. Then I want you to execute the target that's over here on the right. Okay? So let's go ahead and hit save here. Well, I'll tell you what, let's do one more thing. If we wanted to, we could do this, right? If we did this and we typed in like cryptocurrency, and I would have to actually type this out correctly, we could go ahead and that would mean that anything that would come through with the source of GuardDuty, the detail type of GuardDuty finding, and a specific type of cryptocurrency mining or some such, then what would happen is that we would have another and here. And then it would have to be all three of these if we wanted to fire the action or trigger the target. Now, what happens if we do this? Let's say instead of just GuardDuty, we want to also say AWS Security Hub. So if I did this, and I don't think this is actually correct, but regardless, so let's just for giggles, we would have source GuardDuty and then source Security Hub. That would mean and or. So this statement and this statement is an or statement. So it would be AWS GuardDuty or Security Hub. And either way, it would have to be a GuardDuty finding. So this one would actually never really fire, right? Because we would never get to this and then have a GuardDuty finding from Security Hub. Those two things probably won't happen. So this doesn't make a lot of sense. When we start getting into the and ors, you need to make sure that it makes sense and that you've tested it appropriately. Okay? So we're going to stop here because it makes the most sense as to how this whole thing is working. So we'll hit save. Now, we're going to jump over to targets. We've kind of limited ourselves on the left, so we're going to deal with the right side of this equation. As we hit the drop down, hit the target, we get a wonderful Lambda function drop down. I think a lot of people stop here. Based on what I've seen in customers, a lot of people think this is potentially the only option. If we look up and down here, though, we have quite a few different things that we can do. We're not going to do a lot of them today. There's a lot of different things in here, though, that are really kind of neat. We've got event bus from another AWS account, so we can hook this target up to other event buses, so we can shove events to and from other accounts. Fire hose delivery, if we wanted to. SQS is maybe not a bad idea for this. Realistically, we could go ahead and take these findings and dump them into SQS queues and go ahead and have something on the back of that queue that would go ahead and fire and do stuff. We could also use SSM automation, which is actually a really similar system to Step Functions. SSM automation uses the same document concepts that you use with SSM for the SSM agent on EC2 instances, but it affects the API specifically. Kind of neat. If we look at SSM run command, if we had something, an actual finding over here that was like maybe cryptocurrency or maybe something else, we could go ahead and fire an SSM action and just maybe we want to terminate the machine or stop the machine that's running cryptocurrency. We could do an actual run command to do that. Or we could even go up here and say, hey, stop the instance with EC2. So we have all sorts of options here. When we get here, I think realistically, we need to make our kind of second choice. Our first choice was how we're going to limit the events. And the second choice is how are we going to focus on each of these events? And I say that as two choices because when we look over here on the left, we're filtering out some of these events. Now, we could make a choice to say that, you know what, we really don't want to filter that many events, and we want all of the events to go through this filter and then be dealt with by something, a system on the target side over here. So that would mean that, let's say 40% of the events we're going to get through this filter, and they're going to come over here and run these targets. Okay, that makes sense. If that's the way we want to do it, then we have to have a pretty weighty or pretty beefy response side over here to deal with that type of event structure. However, if we go ahead and make this really, really lean, in this case, it's just GuardDuty findings and that's it. And maybe we set up another event rule for Security Hub findings. And then maybe we set up another rule for CloudTrail findings, CloudTrail events that are of specific interest. Things like CloudTrail being turned off, or people activating things, turning CloudTrail off in different regions. Some very different things could happen there. And maybe we want to have a third event rule for that. Maybe there's a fourth and a fifth that's specific to you. In my mind, that's really the easier way to manage this. And personal preference of it, after having done this a bit, I think that's probably the easiest way for most people to manage it. What ends up happening is you end up with 5 or 6, maybe 8, 10 at worst case of these event rules. And then you go ahead over here and you have either a Lambda function that's going to act as a distributor effectively, or you're going to have a step function that's acting as a distributor. That doesn't mean that you can't do it through SSM automation. It doesn't mean you can't do it through SQS. SSM automation does have some limited parallel processing issues. If it's a small batch, however, it may be the right choice for you. SQSQ requires a little bit more work, a little bit more programming on your side. Some of these other things are really good options too, though. I mean, we've got Event Bus in another AWS account. Maybe you've centralized this account. You need to stream it out to somewhere else. It's up to you. In this case, I'm going to go with step functions. And I'm going to go with step functions because I want to be able to see what happens. In an incident response workflow like this, the concept that I'm using here is that I want to be able to send my API a command, and I want to know if that command acts or doesn't act, if it fails out for a specific error or it fails out just as a general error. Hey, we don't know, and it just didn't work. Sorry. It's important for me to know that. In this case, I've already actually written my stateful machine. So kind of cheating, sorry. We'll get to that in a minute and we'll look at what's actually in there. And I'm going to actually have to go ahead and create a new role for this. So I would go ahead and say, this is my new role. Now, realistically, because I've already done this before, I've got a couple of them in here. But for giggles and whatnot, we're going to go ahead and do this. All right. So again, we're going to use a stateful machine. We're going to use a step function because we want to know what happens to these Lambda functions and SSM functions once we get inside the stateful machine. Okay. So we're going to go ahead and do details, configure details, and we'll just call this test. Test 2, actually. And then we'll call this test. We'll go ahead and create the rule. So pretty straightforward, no big deal. Now, one of the things we do want to make sure, since we're just working on this and we're not actually running it, we want to make sure we disable it. And we want to do that so as we go ahead and build things in the step function that we're going to be building, that things don't automatically fire and we halfway through the step function, we find that it's running and we didn't expect it to be. Okay. So both of these are pretty much the same at this point. They both fire on a specific role and they both fire the same response controller 1. Okay. So as we do that, then let's go ahead and jump over to step functions. So step functions is pretty straightforward. Don't, however, miss the fact that this is status active and whether they're running or not. It's important to note how many times things have succeeded, how many times they've been aborted. You can tell that I ran the response controller a handful of times before we recorded this, more so I could make sure everything was working the way we expected it to. But as we look at this, then it's pretty straightforward. It's not rocket science. One of the things that came out of doing some of these is copying to new. It's a lot easier to go ahead and just copy one of these to a new one if they're running a lot, as opposed to trying to just edit the one in process while it has running functions. It can do all sorts of crazy things, and that's not really what you want to do. You really tend to want to go ahead and copy to new, and then you're going to go back to your CloudWatch event and change that rule so it's pointed to the new controller. Okay, so as we get into this. This is a pretty straightforward step function. We're not doing anything rocket science-y here. We're going to do a handful of things. Now, this is the wonderful JSON bit that we all know and love at this point. I'm going to go ahead and shrink some of these so it's a little bit more obvious where the things are that we're playing with. All right. So we start off with a failed function. Does it matter what order they're in? Obviously not. Failed is down here. So as long as I go ahead and look at this and do this in any order I want to do, and I say start at, that's how this is going to work. So I've gone ahead and started with failed. We're just going to stop the whole thing. We're going to go to end state. Now in this case, I've passed it because I didn't want to deal with what happened if it failed. Ingestion action is going to be the action that we're going to take. And that Lambda function we're going to go back and look at is CloudWatch or core. And we talked about that a little bit a second ago. We're going to talk about that again and go see what it actually looks like. As we get into this and look into ingestion type and then which one of these things happen, we've got different steps that we're going to take. So the first thing we're going to do is ingest the actual event. And that means that CloudWatch has sent over the event to our response controller. And we've gone ahead and reviewed what's going on here. Not really. We haven't done any review at all, right? We've just gone ahead and gotten it at this point. And when we get it, we go ahead and just shove it out to specifically this errand. Okay. Step functions can change things, but at this point, we're really doing a very simple process. We are just handing information from one thing to the next. Now, as you look down here, you'll see ingestion type. And this is more of a choice engine. So think of it more like an else statement, right? We've got a variable that we're evaluating, and we're trying to decide whether that string equals one of these things. And if it does, then it's going to go ahead and run this next action. And for this, I've really only got 3 main actions that I'm going to run. And I get it. If this were a full-blown implementation, maybe you have 10 or 15. But I think what you'll find is you end up with about 10 at most, if not 6. We have an emergency action infrastructure, an emergency action account, an emergency action application, the 3 domains that we normally talk about. Emergency meaning that, you know what, we got to go clean something up now. Realistically, I think you're going to have informational and emergency. And that's okay. It's one of those things where it depends on how your company works, but you're going to shake out with a lot fewer than 20 million here. It's going to probably be more like 10, if 10 at most. Okay. So as we look at this, we have to get an idea as to what's doing. Each of these are pretty straightforward. Let's go ahead and look at the infrastructure one. So infrastructure is then going to kick off another Lambda when we get to this point, and it's going to kick off the emergency instance correction. So it's going to go ahead and use this result up here. Actually, that's the result it's going to call. This is going to throw back this result here. Ingestion is going to look at that variable and evaluate whether that variable equals this. We just happen to be using the same variable in the infrastructure action as well. Okay? Cool. I think that's about all we want to do here. And then we're going to jump over to the Lambda. So let's go over to the Lambda. So this is kind of one of those moments where you have to make choices. We talk about the Lambda. Initially, what did this Lambda look like? So initially, when I wrote this was a lot of if-then actions that went through, I want to say 10 or 15 of the GuardDuty event findings. And what I did was to go to CloudWatch, and CloudWatch basically had a rule here that basically went ahead and said all of these findings, send them to the CloudWatcher core instead of the step function. So as we did that, we went back to the Lambda and we looked at the CloudWatcher core. It basically just grabbed all of those events one by one, if then esque, right? And it would go ahead and kick off another Lambda to evaluate that type of finding. So if we had you'll see here, we've got the unauthorized access. If we had an unauthorized access credential exfiltration rather, we would go ahead and make a specific action for that finding. Now you'll note that this is a little different. I worked with a guy named Brian Cody here at Amazon, and he decided that it was a really much better way to go ahead and do arrays. And I think he's right. It's actually a much better way to go ahead and do this. And it makes your code a lot cleaner and simpler. So right now we only have a handful of different things that we're going to run. We've got a critical account and critical infrastructure. I didn't even put together a critical application for the demo because it didn't really seem pertinent. But I mean, realistically, we're going to have one of these for each of the step function items. So let's go ahead and validate that. So if we go ahead and shrink this back down, what would this look like? So in the step function, then, we would have a definition, a specific action, rather, for each of these. So if we shrink this back down again, we would end up having emergency infrastructure, emergency account action. And over here, we would have, well, I called them critical. That's just bad development on my part. I'm sorry. We would call them emergency account, emergency infrastructure, and informational account, right? So pretty straightforward, not rocket science. We're just going to go ahead and fire these things off based on what they're called. All right. I think this makes the most sense, right? Everybody, I wish I could see your hands go up or down whether you agreed or not. I think this is a better way to do it than doing the if-then statements. Again, you're going to end up with a combination of findings. So we're going to have a specifically critical account here. Do we have instance exfiltration? I mean, you could put the Tor node one in here after this, and effectively that's what's going to happen, right? So we're going to go ahead and add Tor nodes here to the end of this, and more and more and more and more. And eventually, these will be quite long, and we'll have a significant number of the different types of findings in each of these line items. So that's what's going to happen there. Now, what happens here? How do we do this? How do we know if this is working? Well, what I went ahead and did when I did this was to copy 2 events from GuardDuty's test finding, and we do that like this. We go here and we go to GuardDuty. And we will go to settings, and we will say generate sample findings. And once we've done that, if we're very quick and Demisto has not yet grabbed my stuff, we will be able to go ahead and look at what the finding looks like in JSON. And so what I've been doing is to say, okay, well, if this happens, then maybe I want to do this. I would want to grab this type. Once I've grabbed, copied that type, I'm going to run back to the Lambda here. I'm going to go into CloudWatcher Core. And maybe I feel like, is that a critical account, critical informational account, or critical infrastructure? Which one do you guys think it is? Is it here? So I'm going to say that if we've got something kicking off phishing domain requests in DNS, that chances are it's probably an infrastructure issue. It sounds to me like somebody's compromised a machine, maybe a Java client or a Java server rather, or something like that. Somebody's injected a process that they expect to be running. And what this is going to do then, as we run through this code, is to go ahead and look at the full event, which is what's come in from the outside, right? That's what we got from CloudWatch and what our step function passed into this specific Lambda code. And I've got an event type. Now, if I look at event type, we don't really see it anywhere here because it's down here, right? When we get this in, we're actually looking at the event and we're grabbing the type. So we're grabbing the type here because I want it to be very simple and very easy up top. And I want my definitions to be easy to use. Okay, so as we go up here then, we're going to see event coming from here, and we're going to see the event type here. So as we look at this then, we're going to run through each of these items, each of the items in each of these arrays, and evaluate whether each of those items then does indeed equal, in this case, the event type. Okay, pretty straightforward. If it does, then we're going to go ahead and return those results. So what does this look like when we run it? We can go ahead and hit test. And yep, it's an infrastructure emergency. How does that look on the other side if we configure the test events, crypto mining or the other one? It's literally just a copy and paste. This is not rocket science, okay? Now, we've seen this. What does this do? Well, to be fair, this doesn't really do anything because the step function is the thing that's firing it. And that's the ideal. And that's really why we like to use step functions here. So if we go back up to the top, what do we do? How do we test this? How do we know if this actually works? Well, we've got a couple of options. We can go back to state machines here, and we can go to response controller. And I could actually go ahead and run it from here. Actually, I can't. I've got to run it from here. I can start execution, and then I would have to go ahead and paste in my JSON and figure out what I'm going to do there. And realistically, I'm lazy. So I'm just going to go there, and I'm going to say a new execution, and it's going to have my JSON for me all here, and everything's going to be happy. Now, the downside is that this is cryptocurrency mining, right? So that's going to be a problem because this instance ID no longer exists. It is gone. So what do we do? Well, we have a pretty limited scope of things we can do, really, right? We can run this right now. Let's go ahead and start execution. And even before we got to the point where this refreshed, we had already jumped down to the fact that, hey, we've got a problem and we've jumped down this path specifically. And now we're done. So it ran down the paths appropriately. It's done all the stuff. And you can tell that currently this ran through the whole function in a little less than, looks like, 1/10 of a second. So that's pretty good. We know that it succeeded. We know if we look at this, we can see that all of these other ones succeeded. And we can see what the actual responses were from the systems. So we can look at this and go, okay, so we went in and the ingestion action looks like it was scheduled and then it happened. Elapsed time in milliseconds. Okay, it was an emergency infrastructure action. Task exited. We passed through the event still. I've got a bad habit of passing my events around. I pass the entire event around because you never know what you might need. I suppose if I was a much better developer, I would pass just the specific variables that I need, but I'm careful. So we're going to go ahead and launch a Lambda function then, and we're going to look at what that did. And it looks like everything went well. I don't see anything that didn't work here. One of the things that can happen though, and let's go back to the code again and look at some of the earlier actions here. If we look at why Crypto 2 failed, why did Crypto 2 abort? So you can see here that I've changed the function, right? And this is kind of one of the nice things about step functions. I can see how it's changed over time. I can look at my step function and see, well, I used to have this waiting ingestion section and this ingestion status. So when I wrote this initially and was getting ready to do this, I thought, well, maybe it would be nice to have an ingestion and status because, if you've got 100,000 events and it's running them through very, very quickly, maybe it's going to get overloaded. And it turned out that that wasn't the case. And it was just much, much easier to remove those things. But we can still see what happened. So it looks like things happened and task exited. Why did it exit? We look at it and it doesn't really make any sense. We don't know why. But what ends up happening here is that we were using variables that didn't exist. Let's see. So if we look at the code, we see that I was results path, and my result path was set to CloudWatch or core. But down here, I was actually looking for value. So we can look at historically why this didn't work. And when I was writing this, it was a real pain because for whatever reason, I just totally missed that. And I spent a good hour dealing with what the hell was going on right there. So, oops. But I've got it historically so I can look back and see, hey, that's actually something that might have been valid. And I need to know why I failed that one. So it looks like we went ahead and had this one work. Looks like this one went to emergency action infrastructure as well. This must have been the crypto test. But you'll note that this one had other issues. We have a failed state here. And as we look at it, you can see that we've got an issue. Is not authorized to perform Lambda invoke function. So what ended up happening here, if we go back to the code, was that at the very bottom here, we're kicking off emergency application actions, right? Let's see if we can get to the specific one for infrastructure. Nope. And yep. This was not able to be run. And you ask yourself, well, why not? Well, it's a pretty easy thing to check. If it doesn't have permissions, then we've got to go check my IAM policies. Now, what does an IAM policy look like for this? One thing that we've got to be careful of, and we have to state this very, very clearly, is that our step functions and our Lambda functions should not have roles beyond what they're supposed to have. So if we look at our Lambda function and we go down here and see what it's running as Lambda basic VPC execution. Okay, so everybody's got that, right? So we go ahead and look at it. That's pretty simple. Doesn't really need to do anything beyond that. And that's okay, we're happy with that. What ends up happening, however, is that that's what the Lambda is functioning as, but my responder is also running as something else. So if we go look at this one actually only has the ability to execute specific JSON or specific Lambda functions. And in fact, I had forgotten to do this one and I had not added it. So initially it actually looked like this. Click. When it looks like this, it's not able to run that last Lambda script. So we had to make sure that that was in there. Now you'll note that that is the only thing that state function, step function is able to do. In fact, it is just able to execute those 5 Lambda functions. Okay. Now it's able to execute those 5 Lambda functions because in the end, what we're doing here is actually running. We jump back over to our step function here. Let's look at it again. So we look at our definition. We've ingested the action. We've decided what action to action ingestion type it is. We know that it's an infrastructure critical event, right? And if we hit run, we'll see green, green, and then it'll jump over here and go green. And we've decided that it needs to fire this. So what is that? So as we look at it, it is this. And it's a function, so we know it's a Lambda. So we need to go look at kickoff emergency instance correction. So if we go over here and we go back to Lambda, we go to instance. What does that look like? Well, it's really, really simple. In fact, it's exceptionally simple because the only thing it's doing is kicking off this state machine, right? It is just kicking off another step function that is going to go through and do an automated snapshot process. So if we look at this again, what's going on is this step function here is running this step function here. And you can see that this step function is already running, in fact. Now, we're not going to wait for this one to finish up because it actually takes quite a long time to work. But what ends up happening here is that it will go through and do all of the processes that we need it to do. So if we look at this step function and actually get into what it's doing, we can see that we've gone ahead and set up a pretty straightforward function. I would call this a workflow. We're not even, I mean, to be fair, barely a workflow, right? Because this is pretty much just a line of stuff that might fail. So we're going to go ahead and create a snapshot. We're going to go ahead and look at that snapshot status and evaluate whether that snapshot status happened in time or not. This is one of the nice things about step functions, right? Because if we take a snapshot of a SQL server, that's going to be a really, really, really long snapshot. So we need to make sure that as we're doing this, it makes sense to do it the way we're doing it, right? We're going to catch any errors here. Then we're going to create volumes. And some of these things take a long time. And we're going to check every 5 seconds to make sure that the volume's done or not. We're going to look for that status. We're going to get the point. And this is stuff that is going to take a while. So as we look at this, we have to evaluate what's going on. Now, you'll note that this one is here. So in the forensics talks and in the incident response talks that we've been giving lately, you'll hear us talk about DD. DD is a way to create an image of a volume or a set of data in Linux. It's a pretty well-known open source command, and it's a good thing to have. When we talk about forensics and we talk about things in AWS, it's great to have a snapshot, but when you do forensics, we want you to do a DD so that if you need to make sure that if you need to use something with thoughts towards attribution or chain of custody, it's something that you can continue to hold on to. DD is helpful from that point of view. It goes into more of your legal department, and I am not legal, so I will not give you legal advice, but it's a good thing for you to know it exists. You'll note that this one actually is going to go ahead and fire off an SSM command. And interestingly, you'll note that everything we've done here is actually Lambda. So if you look back at the Lambda functions, these Lambda functions actually end up acting as kind of the connective tissue for everything else that we do. So if you go through this, you'll see that a lot of these things are actually working on other pieces. So if we look at this graphic again,
we've kind of gone through the left side, and we've talked about that a bit. We've talked about CloudWatch, we've talked about Lambda functions, and we've talked about step functions. And I think now, after having done all of this, I hope that you can see how this middle bit here, where we go from Amazon CloudWatch to step functions to Lambda functions, ends up being more of a circular kind of a flywheel contraption, right? We end up coming around and going around again and again and again. And we might fire off a whole bunch of Lambdas, and we might have a whole bunch of step functions dealing with those Lambdas in turn. Understand that each of those pieces then can go off and communicate with Slack, or they can communicate with AWS APIs and whatnot. And I think as we get to the end of this, the last couple of things that I want to touch on before we close up here is really just this graphic again. And then I'm going to show you a decision tree. And it's kind of one of those things that, we've talked about how to do all of this stuff, but to get to the point where you're actually coding, it's important that you take a step back and you look at how this decision tree is actually going to flow for you. So the next thing we're going to look at is a decision tree that a friend of mine named Ryan Cody actually wrote and came up with recently. And then we're going to look at something from Demisto, which is a third-party partner that we have that kind of did the same thing. And it's kind of a neat scenario to look at both of those things and see how they fit together real quick. And we actually start talking about a decision tree. You will note that Ryan did a lot of really cool things here. He tried to work through exactly what would need to happen in an event of, in this case, cryptocurrency mining. So if we look at this, right, the first thing we want to do is, hey, let's tell the on-call that we've got issues. We've got business owners that might need to know. We have security that might need to know. Now, why is he calling out to security and the business owners? Well, that's kind of an interesting thought. Maybe the business owners actually want to know that that's happening as well, just in case the security guy happens to have fallen down and is not able to get to the keyboard right now. There are all sorts of reasons that you want to make sure that more than one set of people might know. Now, it might be fine. Maybe you've got a NOC or a SOC, and you're using that item or those people to deal with this, and that's great. Maybe you've got 5 or 6 of them. Maybe you've got a distribution list that you're sending to. But all of that's happening on the backside, right? We need to make this choice right here, and we need to decide who we're going to send that information to. Once it gets past this point, we're good. So as we go further south here, you'll note that we've got an AWS support ticket. Always a good idea to create an AWS support ticket if it's something that you think you need AWS support help with. You may not. Realistically, some of these you don't really want to create an AWS support ticket for. It's not really pertinent. However, if there is something that's going on, maybe that's the time to do that. So you want to look internally and decide, when is that okay? When do we need to do that? And legally, you might not want to do that sometimes. Maybe your legal department has something to say about that. As we get further down here, you're going to note that there is an instance launched with an IAM user, right? So if this cryptocurrency is going on and it's actually an instance, is that different than, for instance, my application having a function injected into it and having that application then begin to currency mine? Absolutely. The instance being launched with an IAM user would tend to specify that there's actually an IAM breach too, not just an EC2 instance that's acting oddly. So we split into 2 different kind of camps here. We have to look at what would happen on the yes answer and what would happen on the no answer. And I'm not going to bore you all with the walkthrough here. But as we get through this, you'll note that it's really, really, really simple. It's not a 2-paragraph question. It's a barely 1-sentence question. Sometimes it's not even. If you look at some of these, though, it's only yes and no. There's no maybe, right? There's no question of gray in this. It's white or black. Does the instance have a role attached? Yes or no. It can only be one of 2 answers. And the reason for that is because as we take this document and we begin to look at what it would turn into as far as code, the simpler we have it, the better, because the more simple document, the easier it is for that Python coder to sit down and do that work. Specifically, does the instance have a role attached? Well, I can run a describe call and get that for you very, very quickly. In fact, it's actually in the event maybe even. And if it is, then I can go ahead and act on it right there without even having to run a describe call on it. Are we going to create forensics? I don't know. But I tell you what, it's not in the event. The only people that are going to know about this one, that's your legal department. They're going to tell you whether or not you're going to do that and whether you need to do that. So make sure that as you go through this, you've shown it to a whole bunch of people. Now, kind of fun side note here. We get to talk about a lot of things in security, and one of the things that is always out there is the fact that security people often get blamed for bad things, partly because we're around when bad things happen. but partly because we don't often communicate well to the people that we work with, developers, managers, and executives. So this is one of the ways that we can actually communicate with those people and show those people what we do and why we do it. And when they start helping us with these answers, then they're going to feel more invested in the final answer, and they'll feel like they own the solution. And that's important. As we look at this, we want to make sure that the people we work with are invested and understand where we're going. And to that end, I had mentioned that I was going to go ahead and show you Demisto at the beginning of this, and I want to make sure that I do. We don't want to get to the end of this and forget that.
And it's one of those things I definitely wanted to cover toward the end of here. We have to make sure that you get to see this. I think mostly because throughout this whole thing, we've talked a lot about how to write a Lambda code and get Lambda A to call Lambda B, or to get step functions to call other Lambda functions or other step functions, and SSM and automation and all sorts of different internal Amazon-only products. And I think that's totally something that you guys can go out and do. You can sit down and code a bunch of Lambda and do some step functions and get to the point where you've got an incident response system that you've built and you understand, and your team basically had a hand in creating. And I think that's really good. I think it's good for customers that have the ability to do that and the depth, the team depth to do that, to take a really good look at that. On the other side of that equation, however, and I think we would do the rest of our customers a disservice if we didn't say, hey, we've got partners out there that do some of this stuff for you, or it can at least help you with understanding what it would look like to do this. And we talked about Ryan Cody's decision tree, and I think that's important. But as we look at this, I want you to get to the point where you look at other third-party products too and say, wow, you know what? That's, more than half, more than 80% of what we just looked at. And it came out of a box. And I got to be honest, it took me like 3 hours to set this up. So it's not rocket science. This is pretty good stuff. And it comes out of a box and you're done. So from that point of view, let's take a quick look. I mean, we've got CloudTrail being what? Let's see, CloudTrail was disabled. Oh no. Kind of a big deal, really, when you look at this. I mean, it's important that you would know that, and we want to make sure that it gets turned back on, right? So as we look at this, kind of a big deal, kind of something that we ought to know about. Maybe we don't agree that the severity here is low. Maybe we should want to change this to critical. I mean, this is end of the world, apparently based on the graphic type of stuff. And that's great. And do I actually want to go ahead and say waiting for manual review? Maybe not. Maybe I want to do something else to this. But all of this is clickable, and I don't have to write any code to get it done. So as we look at this, oh, I get it. It was something that I totally generated just to make sure that everything was okay. And yeah, I get it. If you look at the main Demisto screen here, I've got like 96 high findings. And we can click on that and see all 96 high findings. But you know what? This is just the demo events that you get from clicking sample events in GuardDuty. So not a big deal, I suppose. But as we look at this, we do want to be able to see this, right? I mean, if this were really happening in my account, I'd want to know that that's happening. And now you can see that it does. So as we look at the high severity events, if I wanted to change it, I could. If I wanted to limit it, I could. Really not a demo for Demisto here, but I did want to show you one more thing. So as we look at this and we say, let's see, generate findings. Where was the last one that I wanted to show you? Data exfiltration is a good one. So let's go ahead and look at data exfiltration, right? We've got some data going out of our AWS environment, obviously from one of our make-believe servers. But that said, we've been able to go ahead and set up a task. Now, what does that task look like? Well, if we go to the work plan, which is kind of Demisto's runbook of things, we get to be able to see something that looks surprisingly like what Ryan did for a decision tree, right? And Demisto does a really good job of giving us some prepackaged decision trees that allow us to go through as non-coders if we wanted to be, or really small teams, and get something that is really useful for our little team or our non-coding team. We can go ahead and say, these are all the things that we want to have happen. And we want to alert and escalate. That's wonderful. In one step, I've got the ability to go ahead and send an SMS message. I can go ahead and alert my Slack channel and escalate to critical. Really important things to do. And if I really want that to happen up here, I can go ahead and do that instead. So I think Demisto's really done a great job of just getting this into one place for users that really aren't ready to sit down and spend the last 30, 40 minutes that we talked about. They just really need to be able to click a button and go. Important stuff. They have a lot of neat stuff here too. If you want to get into the different items that Demisto has, I'd suggest you give them a call. I think the point here really is that it's a lot more than you're going to be able to sit down and code yourself in any short amount of time. And it gives people that don't necessarily have a deep technical background the ability to get into incident response and get into addressing incident response in a meaningful way, as opposed to just ignoring some findings or ignoring things that are happening in their environment. And let's be honest, I mean, we're all dealing with more and more information these days. And as the cloud gets bigger and people begin to go to the cloud more often, we all need to be able to respond to things a little bit better. So I give Demisto a big thumbs up for being able to help our customers that really don't want to sit down and code, or really just want to be able to open the box and get it done, to help them get what they need done. It's good stuff. So with that, I think we're going to go ahead and call this webinar closed. We're going to go ahead and discuss a couple more things in Q&A probably, but I think other than that, we are good to go. So if you have questions, please feel free to ask, and we will get going.